Hello, everyone, and welcome to today's webinar. This is the fifth in our series that is focused on various aspects of gut health and gut microbiome. My name is Marie Latulip, and I'm pleased to serve as the director of IFANS, or the Institute for the Advancement of Food and Nutrition Sciences. And as we start the program, I would also like to introduce Dr. Maria Pachulu of the University of Buenos Aires, who will serve as the moderator for this program. And just to give you a little bit of background, she received her PhD in pharmaceutical sciences and biochemistry from the University of Buenos Aires in Argentina. And she's currently a professor in practical works at the Department of Physiology at that university. And her professional memberships include serving as an international member of the Academy of Nutrition and Dietetics, and she joins us as a moderator in that role today. We're very pleased to offer this webinar to you as a collaboration across the three groups that you see here. And to give you a little information about those groups, IFANS, which I represent, is a nonprofit organization that advances food and nutrition science for the benefit of public health. And we do that by bringing together scientists from industry, government, and academia. Dr. Pachula will briefly cover the other two collaborating groups.
Thanks, Marie. The Academy of Nutrition and Dietetics Research Practice Group brings together registered dietitian nutritionists with a particular interest in nutrition-related research, and any RDNs in the audience with this interest are encouraged to join for additional value and benefits of membership. I'm honored to be a member of this practice group and to serve as your moderator for this excellent program. Finally, the American Society for Nutrition's Nutritional Microbiology Research interest sections brings together investigators who explore interactions between dietary compounds and the microbiome.
Great, thank you, Dr. Pachulu. And just to note, this webinar is approved for one continuing education credit by the Commission on Dietetic Registration, and we'll give everyone access to that certificate following the webinar. Before we start, a quick note on logistics. On this slide, you see a picture of the control panel, so hopefully you also have that on your desktop. And we'd like to point out the questions box, and we encourage everyone to go ahead and submit questions as the presentation goes forward, and that way we have a good sense of what you're asking before we get to the Q&A segment, which will be at the end. And your questions will only be viewable to those of us on this side of the platform, not to the entire audience. Before we start, we wanted to get a sense of the audience by trying out a live poll. So before we show you the question, the instructions are on the slide here. So there are two ways you can find the poll. So you want to choose using your browser or using your phone. And then depending on which one you choose, you'd either go to the website shown here, or you send a text to this number 22333. And the text is IFANS Connect 300. So we'll give you just a couple of minutes, seconds to choose one of those and to get that set up. And as you're doing that, just note that you can respond to this question multiple times. So it's a select all that apply question, but you might want to just read through the possible answers before you choose and then provide us your answer. So the instructions are also going to be on the next slide. Okay, so people are already responding. I'll turn it over to Maria to review the question and then talk us through what people are saying.
Okay, before you respond, be sure all of the possible answers. You can respond more than once if you want to choose more than just one answer. The question as noted on the slide is, which foods contain potentially beneficial live microbes? We will give a second to respond.
Looks like it's slowing down a little bit there, Maria.
Yes, we have some questions, some responses coming in, and we can see that most of you immediately think of all of the above with 30%, and then yogurts with almost 27%, and few consider microbes on fresh fruits and vegetables to be a source of beneficial live microbes in foods. The answer is actually all of the above, with these foods providing microbiome in varying quantities, and we will learn about that today. Let's get right into today's program. The learning objectives are shown on the slide here and include supporting participants' ability to define and identify the similarities and differences between live microbes, probiotics, and fermented foods. Describe the sources of live microbes in the diet and the extent to which these microbes are part of the American diet. And lastly, describe the state of knowledge related to health benefits of live microbe consumption. With those objectives in mind, I'm pleased to introduce our future speaker, Dr. Bob Hawkins, who is the Ken Shahani Distinguished Professor of Food Science in the Department of Food Science and Technology at the University of Nebraska. The Hawkins Lab studies bacteria important in human health and in fermented foods. The lab is particularly interested in understanding how diet and dietary food components influence the bacteria that reside in the gastrointestinal tract. The main goal is to understand and predict how diet-induced shifts in the microbiota ultimately influence human and animal health. The Hawkins Lab also conducts clinical studies to assess the effects of prebiotic and probiotic interventions on gut barrier functions and other health outcomes. From 2016 to 2022, Dr. Hawkins served on the board of directors of the International Scientific Association for Probiotic and Prebiotic, ISAPP. We will turn it over to you, Dr. Hawkins.
All right, hopefully everybody can hear, and I'll get started. So thank you very much for the introduction to, here we go, from Maria, and I want to thank Marie and IFNs and AND for this invitation to present. I noticed that most of you got the pop quiz question correct. I know that it was a little bit tricky, and my students always accuse me of being tricky on those questions. So, but it looked like most of you did pretty good on understanding the microbes that we eat, which is the topic for today. I also want to note that I have a one disclosure to make. I have been a recipient of grants from food and supplement companies, and I'm a founding partner of a startup company called Symbiotic Health. Okay, so let's get started. So what are Americans eating in 2023? And I think this is an audience that probably knows the answer to this question. And it's, for many of us, it's the Western diet, the so-called Western diet, shown here: a muffin and a coffee for breakfast, fast food for lunch, some cookies for a snack, and some sort of frozen microwavable entree for dinner. And unfortunately, that is a failing. That menu for the day is gives you a failing grade based on this healthy eating index. That's part of the diet. It's based on the dietary guidelines. So we're not doing a very good job eating in America. In contrast, there's the so-called Bob diet. That's my diet that I try to keep. but not too many of us follow the Bob diet. I can't even convince my family to follow the Bob diet, but it's basically yogurt with granola for breakfast, a salad for lunch, fresh fruit for snack, and my infamous Tempe Reuben sandwich for dinner. So apart from the sugar, the fat, the salt, the calories, and all the macro and micronutrients, what's the main difference between these diets? That's kind of a rhetorical question, but what's the main difference here? I would contend that it's the live microbes plus the prebiotic fibers that gut microbes will grow on. So this brings me to the outline for the next 40 minutes of this talk, the importance of live microbes in the human diet. So first, we'll discuss for several minutes the rationale for eating live microbes. We'll talk about which foods are good sources of those live microbes. And does it matter which microbes we eat? Is one microbe just as good as another? And going back to the pop quiz that we saw, the microbes that are in fresh fruits and vegetables are clearly different, as we'll see shortly, from the microbes that are in yogurt or fermented foods. And then what is the evidence to support this very hypothesis that we should be eating live microbes? So first of all, I should point out, I give this talk to often to nutritionists and sometimes even to lay audiences. And even my own students, I gave a lecture many years ago on the importance of live microbes, fermented foods to undergraduates. And I talked about a spoonful of yogurt containing 1 billion microbes. And a student reported back to me that he went home and brushed his teeth for 20 minutes to try to get rid of those microbes. Well, unfortunately, it's a microbial world. And so if you don't like bacteria, you got to find some other planet to live on. Indeed, there's many live bacteria and just in that cup of yogurt as there are humans on the planet. So the idea of this live microbe in our diet goes back to, well, goes back many years, but it certainly was articulated really well by my colleague Colin Hill at University College Cork, who wrote this essay in The Biochemist, an RDA for microbes. And he posits that in addition to RDAs for nutrients and vitamins, that there should be some sort of dietary guidance for consumption of safe microbes in the diet, perhaps by fermented foods. So this was a real intriguing idea. And the ISAP organization that Maria mentioned before, the International Scientific Association for Probiotics and Prebiotics, we meet annually, and we actually had a session devoted to this topic. And out of that session came the live microbe panel that was charged with assessing this very question, starting with the estimation of how many microbes are in foods, and then trying to model that consumption with disease risk. And on the panel, we had terrific colleagues, microbiologists, food scientists, nutritionists, statisticians, and we even had my colleague Dan Merenstein, who's a family practice physician. So a terrific panel assembled to address these very questions. And we've been very productive. We've already had 2 papers published, and I'll talk about some of the data from these papers. The first paper was simply the rationale for proceeding down this path. And then we published the part 1 of the results, which ranked foods based on how many microbes they had. And a third paper, which is now in review, relates, is the main part of the study, which relates those microbes that we consume to health outcomes. Okay, so what is the rationale for eating live microbes? And this goes back to what many of you probably have heard of, the hygiene hypothesis. And this has gotten translated into the New York Times article, invite some germs to dinner. But it's not really, and sometimes you'll even hear this notion of eating dirt, but this is a theoretical rather than practical advice. But indeed, having a pet in the house, consuming probiotic microbes, whether they're in supplements or in foods, even just sending your kids to daycare are factors that can protect against development of immunological diseases like allergies. And this hygiene hypothesis has now been kind of renamed the old friends hypothesis, the biodiversity hypothesis, but the central aim or the central thinking is that industrialization has led to a decline in biodiversity of microbes, which has led to this dysbiosis and disturbed immune system, resulting in a high degree of inflammation and inflammatory, a high risk of diseases of immune origin. Now, it's not just diet that we're talking about, but industrialization and its effect on the microbe starts in early life. How we're born, whether we're born in the OR, that's not where we want to be born. What we consume when we're infants and babies, not from a bottle, it should be human milk, preferably. And we take way too many antibiotics. And these early life events can imprint this industrialized microbiome for a long time, for life perhaps. We have a sedentary lifestyle that can contribute. And we have this compulsion with hygiene, this germophobic attitude that many of us still have, even through COVID. I understand washing hands and use of sanitizers for the last 3 years has been in daily practice, but nonetheless, it leads to a diminishment of diversity and of microbes. And I'll give you two examples, two really good examples of how this industrialized microbiome has affected disease risk. And we'll start with this study in Finland, which is, I think, a really cool study. Finland, of course, has a very hygienic lifestyle. And prior to 1960, these diseases of asthma, atopic eczema, and allergic rhinitis were basically non-existent. And you could see this increase in the post-war 50 or 60 years. And the authors claim that it's due to changes in environment and lifestyle affecting microbial exposure that have played a role in this allergy epidemic that created a very significant disease burden in Finland over that period of time. It's starting to plateau out now. Another really good example of this so-called hygiene hypothesis is the incidence of inflammatory bowel diseases that, again, were nearly non-existent 60 or 70 years ago, but now in the Western countries, in US, Western Europe, Northern Europe, the incidence or the prevalence of IBD is 20 to 50 times higher than in the developing world. And this is also shown in this trajectory of IBD, shown down here, where in the Western world, we're around right here. You can see this huge increase in just the last 60 years. Newly industrialized countries are following the path of the Western world, and developing countries are still way down here on this trajectory, way down here low, but it's even anticipated that as they move up to becoming more industrialized, that there'll be more of an increase. And again, the authors claim that it's the main risk factors are urbanization, hygienic environments, and diets low in dietary fiber, which ultimately contribute to the gut microbiome. So here's, again, another illustration of what's happened in human history, where we had our early human diet was full of fresh foods because it was predated processing. So all the foods that we ate were unprocessed, led to high microbial diversity in the gut, trained our immune system to be more tolerant of potential antigens. Adaptation to modern life led to an industrialized diet with low microbial diversity and untrained immune system that was prone to inflammation. So what we're proposing is that exposure to safe microbes, especially early in life, but even throughout life, a microbe-rich diet can restore diversity, retrain the immune system, leading to greater tolerance. And I should point out that microbes can be enriched in the gut a couple of different ways. One way is by consuming live microbes, but of course you can consume, as I've kind of alluded to before, to diets rich in fiber, which can enrich the commensal microbes that already live there. And again, I've emphasized the immunomodulation as key to reducing disease risk, but live microbes can serve a whole range of functions in the gut. In particular, they can enhance gut barrier function, they can produce vitamins and enzymes and exopolysaccharides, but in particular, they will produce a range of end products, including short-chain fatty acids that can antagonize or inhibit pathogens, that will then produce fewer toxic metabolites and reduce cancer risk. The short-chain fatty acids can also feed and enrich the colonocytes, and they can lower the pH, which can increase mineral absorption. This just is a handful of potential benefits of beneficial live microbes in the gut. So I need to first introduce a caveat, an important caveat. Industrialization has its good side. So prior to pasteurization in the early part of the previous century, so in the late 1800s, early 1900s, prior to pasteurization, raw milk carried horrible pathogens, not just salmonella and listeria, but tuberculosis was found, it was frequently found in milk coming into London, into New York, other urban areas, heavily contaminated. So food processing has made foods safe, long shelf life, year-round availability. We certainly don't want to throw the baby out with the bathwater. Food processing has been good for, and it overall has been good for food safety and even nutrition. But we've lost dietary microbes due to processing and improved hygiene. So hopefully I've convinced you that, that we should be eating live microbes. And now the next question is, which foods are good sources? And so what the panel did to survey foods for microbes was to use the NHANES database. And many of you are probably familiar with this database. It's a large, more than 70,000 participants, cross-sectional survey based on dietary recall. It's collected every other year, so we have longitudinal data, which I'll show you in a few minutes. And it's also possible to correlate consumption to health status. So this is a very powerful database that we relied on. In the database, there are nearly 10,000 food codes, and I'll show you some examples of that in a minute, for individual products. And what the team did, our team consisted of 4 experts, 2 teams of 2, and we individually ranked each product in this database for microbe content. And we had 3 categories. Low was 10 to the 4th CFUs. CFUs are microbes per gram. A medium category, 10 to the 4th, 10 to the 7th, and then a high category greater than 10 to the 7th. We worked independently, and there weren't very many disputes, but when there were disputes, we reconciled them by discussion, and we relied on published literature, including both primary studies, surveys, reviews, and so forth. Now, it would have been nicer had we had, it would have been statistically better, if we had categories that were a little bit more precise. These were sort of arbitrary, but and we would have liked to have, again, more precision, especially on this greater than 10 to the 7th. But this was really all that was practical at the time, and still is. Okay, so here's how the database looks when we reviewed it. So you can see food code, and it has a description. This might be a little bit hard to see on your screen, but no matter, you can see that the category, these are your frozen pizzas, and you can see it's very stratified. Frozen pizza with meat and vegetables, extra vegetables, and so forth. So a lot of different food codes. But for the most part, here's frozen pizza, frozen looks like frozen processed vegetables, canned beans, and so forth. So it's pretty easy to go through these thousands of food codes because these are all low, 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 low. Pretty easy. Pasteurized, heat-treated products like milk, meat that was either coded as cooked, like cow head cooked. I'm not sure what that is. Roast cooked, but even meat that was intended to be cooked were all assigned lows. So we went through a whole bunch of those pretty quickly, actually. And then finally, we get to foods that were in the medium category. And these are almost exclusively fruits and vegetables, or occasionally a sandwich that contained cheese that would have been in the high category, but because it was diluted with bread and so forth, was in the medium category. So the medium category is mostly fruits and vegetables. The high category were, as you might expect, fermented foods like yogurt and cheese, sour cream, and then sometimes foods made from those where the fermented food was a main ingredient, such as so where is it, like tzatziki dip or spinach dip that was made with yogurt or sour cream. Those were in the high category. Okay, so here are the overall results of our estimates of live microbes in more than 9,000 foods. So in this low category, 96% of the food codes are in that category. That's not to say that it's 96% of the foods we eat are in that category, but 96% of the foods that were listed in the NHANES data were in that category. The medium category, which is mostly fruits and vegetables, at about 3%, and unheated fermented foods, and I emphasize unheated. A lot of the sauerkraut and pickles that you might buy at the grocery store have been heat treated, so we were able to exclude those. But nonetheless, unheated fermented foods only accounted for 1% of the foods in the database. Okay, so now we looked at this in more detail, and I'm just going to highlight the three main observations from this analysis. So first, about 2/3 of the population are consumers of microbe-containing foods. So that means 1/3 of the population do not consume microbe-containing foods. They're on that Western diet that I alluded to before. Okay, almost exclusively on that Western diet. Means that they're not eating fresh fruits and vegetables. They're certainly not eating yogurt and fermented foods. Okay, and the statistics here show longitudinal data. So there's been a slight increase in the medium and the high, and we combined the medium and the high, a slight increase. I should also point out that probiotic consumption was also assessed, not probiotics in the yogurt, but probiotics as supplements. And it was just a little bit over 2% of the population consumed probiotics. And then again, longitudinally, there was a slight increase over the last 20 years in the consumption of the high category foods. Okay. Second observation is that we eat about 90 to 120 grams for adults of microbe-containing foods per day. That's about 25% of the total amount of food that we consume today contains microbes. And again, longitudinally, there was a slight increase in these categories in children, and slight increase, not much of an increase to me, but not statistically, it was a slight increase over the last 20 years. And then when it comes to actual numbers of live microbes, we had to do some estimating because of the way we assembled these arbitrary categories of medium and high. But it was pretty clear that that most of the live microbes that we consume per day, about 100 million, come from fermented foods. And you can see that no big surprise, but the lowest category of consumption of live microbe foods were teens and adolescents who don't consume very much. And as you get older and maybe adopt a more prudent diet, you could consume more fruits and vegetables, fermented foods, and so that consumption is way higher. And overall, again, we consume about 100 million microbes per day. Now, when we look at other studies that have also tried to do estimate live microbe consumption, these two studies here that I'm showing here, really nice, really good reading material if you're interested. But they gave pretty gross estimates, not really data-centric estimates, but they nonetheless came up with very similar numbers: 10 to the 8, 10 to the 11th, 10 to 10 to the 11th ingested per day. This study I really liked. It's a short little study, but what they actually did, they took typical diets like the USDA diet plan, and they put the food in a blender. This is kind of, for those of you that remember the old Saturday Night Live Bassomatic, that's what this is. They put all the foods in the blender, blended it, and did plate counting, and they ended up with very close to the same number that we got, 10 to the 9th CFUs per day on the typical American diet. Now, it also provides some kind of cultural context. It depends on where you live and the kind of cuisine that you eat in the country that you live in. So in the United States, we consume, maybe 1 serving of yogurt per week per person. In the Netherlands, they consume that same serving of yogurt every day. And so if you live in the Netherlands and you eat a typical Dutch diet, which has yogurt every day, you're getting just from the yogurt, perhaps 10 to the 10th, 10 to the 11th microbes per day. Likewise, if you live in Korea and eat the typical kimchi-centric diet, again, about 100 grams per day, you're getting, again, 10 to the 9th, 10 to the 10th, just from the kimchi. So if you're eating a fermented food-rich diet, you could easily be getting 10 to the 10th, 10 to the 11th. I should also kind of point out some context that 1 billion sounds like a lot of microbes, 10 to the 9th or 10 to the 10th. Your gut contains about 10 to the 14th microbes. So, you're going to, those dietary microbes are still going to be outnumbered, maybe 1 million to 1. But that's not to say that they're not contributing. So the Bob diet has yogurt, has salad, fresh fruit. My Reuben sandwich I talked about has sauerkraut, has cheese. So I'm getting, again, about 10 to the 10th CFUs per day. And the Bob diet is just the prototype of a high microbe diet. Again, yogurt is the easiest way to get microbes into your diet because most US yogurts have the yogurt microbes. 90% of them have a lactobacillus or a bifidobacteria that's added as a probiotic. So just from the yogurt, you're getting a lot of microbes. Okay, so the question again that that's front and center is, can microbe-rich diets affect human health? And in addition to the NHANES providing all the data that I've already talked about foods that we eat, it also importantly includes interviews, physical exams, and health assessment data so that you can relate diet to disease and health indicators. And it's a whole range of those disease and health indicators that can be assessed. And so that's what we did next. And this was 2 members of our team had the statistical wherewithal to perform this analysis, Dan Tancredi at UC Davis and Vic Fulgoni, who was a consultant with Nutrition Impact. And so they did the appropriate statistical test, which I'll show you in the next couple of slides. But basically, these are regression analysis to assess the relationship between foods with live microbes with the physiological parameters that NHANES assesses. And so I'm just showing you the data that, and this is a in review study. Hopefully this will get published this spring, but we'll have to wait and see. I'm just showing you the statistically significant outcomes. And you can see that these are, I'll also point out, these are associations. These are not causal. These are strictly associations of foods that contain medium or high content of microbes with blood pressure, BMI, C-reactive protein, glucose, cholesterol, insulin, triglyceride, waist circumference, and weight. And you can see foods with high and medium levels of microbes positively correlate with improved health outcomes for a number of different parameters. When we look just at fermented foods, so these are foods obviously in the high category, we see very similar results, improvements in blood pressure, BMI, cholesterol, HDL cholesterol, insulin, triglycerides, waist circumference, and weight, all statistically significant. So the main outcomes of that analysis were that consumption of foods that contain high levels of live microbes associated with several improved health outcomes. And we would say that these health outcomes can be achieved by modest changes in diet. Adding, if you ate the appropriate number of servings of yogurt and fresh fruits and vegetables, you can achieve that. In addition, especially for the fruits and vegetables, but even for the yogurt and fermented foods, they're also good sources of other nutrients, macronutrients, vitamins, phytochemicals, and so forth. And again, we're not showing causality in these studies. We need RCTs to do that. Now, we're not hopefully our study, as I pointed out before, is in review and will come out, will be accepted and come out this spring. But we published those first 2 studies that categorize the microbes into the different categories, and anybody could take that data and do their own analysis. And indeed, a group from China did exactly that. So this study came out just earlier in 2022, and using basically our data of low, medium, and high, they showed that live microbes improved several or a couple of coronary diseases, including stroke and heart attack. So it's very, so was disappointed that we got beat on, somebody else beat us to the punch on this one, but it's still good to see that the data is being used, which is really the main purpose. Okay, so now I want to, again, focus on these 2 categories that contain the live microbes, especially these fresh fruits and vegetables, which were in the medium category. And so, as you all know, you have nutrition backgrounds. It's really not much of a news flash, but fruits and vegetables are simply good for health, whether they contain live microbes or not. More fruits and vegetables that we eat, the longer you live. Fruits and vegetables also contain fiber, which will change the microbial diversity and improve your gut microbiome, just again, apart from the microbes. So it's a tough question to ask, are those foods that in that medium category, the fruits and vegetables, is it the live microbes? So if I go back to the slide, so even foods that contain medium levels of microbes, we're still showing benefits. So how much of that is to the microbes and how much of that is to the nutrients in those foods? So these are part of the outstanding questions that we are currently trying to address, is how to distinguish between the live microbes versus the nutrients present in those foods. So that's a tough question. For yogurt, you could do a study in yogurt, a clinical study in yogurt, because you could make the yogurt with live cultures. You could make yogurt theory. You can make yogurt acidifying, and so you could have a placebo-controlled study with yogurt. But it's hard to do that with fermented vegetables and fresh vegetables, or microbe-free vegetables. Suppose you could take fruits and vegetables and irradiate them, but that's not a very good way to proceed. In the kimchi world, what they're doing to assess the role of live microbes is they're making fermented kimchi. So this is a crossover study, or kimchi that hasn't been fermented. So it's basically the fresh cabbage and greens and so forth, and do a study that way. But again, that's a fermented food versus a non-fermented food to assess the role of live microbes in fresh fruits and vegetables versus fresh fruits and vegetables without the microbes. That's a tough one. I suppose if we could go into the NHANES database and try to call out the fresh fruits and vegetables that were in cans that were heat processed, but I'm not sure we have enough, if the NHANES data is rich enough for us to do that. Okay, and then finally, I want to spend just a couple of minutes on this last topic. Does it matter which microbes we eat? Is one microbe just as good as another? So of the microbes that we find in foods, a bunch of them are firmicutes, and in the firmicutes, there's lactic acid bacteria, which I think we could generally say are potentially beneficial. Another large group of microbes were what we used to call proteobacteria. They have a different phylum name, and they contain plant microbes. So these are the microbes, Pseudomonas and Gluconobacter and so forth, that are in fresh fruits and vegetables. There are also these pathogens that are occasionally in fresh fruits and vegetables, hopefully not. And so when we look at what are the microbes in fresh vegetables, the lactic acid bacteria are only present at about 1,000, whereas these other ones are present at 1,000,000. So they're way outnumbered, 1,000 to 1, the potentially beneficial microbes. And this is supported by a whole range of more recent data. This is 16S sequencing data. And again, this is in spinach and lettuce. The green bar, the most abundant microbes, are these proteobacteria, which are just plant microbes. And if we look at by family, where we drill down a little bit further, lactic acid bacteria are in this yellow. I don't hardly even see any yellow in this stack bar plot. And again, more recent data. This is just data just came out showing abundance of live microbes in salad greens. And again, there are no lactic acid bacteria that are the blue says lactobacillus. I don't know if you can see that. I hardly see any blue in here. And again, when they did the same analysis by plate counting, lactic acid bacteria about 1,000, the other guys 10 million. So they're way outnumbered. And these plant-associated microbes are just typical epiphytes that probably don't even make it into the GI tract. They probably don't survive the stomach. And if they get into the GI tract, they probably aren't very numerous. But again, I want to just suggest that it doesn't preclude that those plant microbes do not have an immunological impact. And I finally want to just make the point, because I think it was in the learning outcomes, and I get asked this question all the time. This is just sort of my summary slide. Sources of live dietary microbes are mostly fermented foods, probiotics, and here's the point that I wanted to make. Probiotics can be in a supplement, Sometimes you'll see them in a bar, a nutrition bar. They can be added to a smoothie, a fruit smoothie. Probiotics can be added to yogurt and to kefir, but probiotics are not the same as fermented foods. And this question is so important that we've addressed it. The ISAP panel has addressed this twice in our consensus paper on probiotics and on fermented foods. By definition, probiotics, that term should only be used when there is a demonstrated health benefit, a clinically proven health benefit conferred by well-defined and characterized live microbes. Fermented foods, for the most part, do not contain characterized microbes. They're uncharacterized, undefined, so that kimchi that you buy or the sauerkraut that you buy will be different from batch to batch. The microbes may very well have similar functions as probiotics, but we can't call them that. Okay, and so fermented foods are not the same. And so with that, I'll conclude just quickly. We need RCTs to address the role of live microbes on health. These association studies are really nice, and we like them, but I do think we need causal studies to really get to make the decision on whether these should be part of dietary guidelines. And with that, I will finish. Maybe we're not too far from the following. Fermented foods, including those that contain live microbes, should be included as part of a healthy diet. So we should add fermented foods, and maybe even a glass of red wine, even though it doesn't contain live microbes. Acknowledgements, again, thank my panel, terrific working group. And I should point out there's an infographic now posted on the ISAP website, and I think Marie is going to post the link to that as well. Basically, everything I've talked about in the last 40 minutes, right on one page. Okay. So with that, I'm going to stop sharing. Come back.
Thank you, Dr. Hopkins. We can now shift into addressing some of the many questions from our audience. And before we do that, we wanted to know that the infographic mentioned by Dr. Hopkins is available at the link posted in the chat, so please check that out. Now to take some of your questions. Okay, the first question is, does yogurt made with coconut milk contain live microbes? And if so, is it considered in the low, medium, or category?
Yeah, nice question. So the plant-based milks, plant-based yogurts are obviously becoming very, very popular. They do have cultures, and those cultures are often very similar to the cultures that are added to milk, to bovine milk yogurts. So they're there. They would probably be in the high category, greater than 10 to the 7th.
Okay. The following question is, how do we ensure that the viability of probiotics in baked foods during processing?
I'm sorry, Maria, could you say that one more time?
Yes, of course. How do we ensure the viability of probiotics in baked foods during processing?
Okay, I missed the viability
in baked products.
Oh, baked foods. Okay. Yeah. Anything that's heat treated, whether it's on the stove or in the oven, if it's baked, will inactivate the microbes. So there won't be any in there. So if you made followed a recipe and it had some sour cream or some yogurt into a cake or a pie or something like that, and it got baked, the microbes are not alive.
The following question is, when we consume frozen fruits and vegetables, are the microbes intact and beneficial like like or like heat processing, does it render them useless?
So most fruits and vegetables will be blanched prior to freezing to inactivate enzymes. And that blanching is going to affect the microbes. So for the most part, we categorize those in the low category. So less than 10 to the fourth. It doesn't mean a canned food, those microbes are, those foods are for all practical purposes sterile. But a frozen food or a frozen vegetable or frozen fruit may contain low levels, but definitely below the 10 to the 4. So we put those into the low category.
Thank you. The following question is, you've talked a lot about foods. Do you have further comments about microbes in
beverages? So we did include, so in the foods that we considered, there were kombucha, fermented beverage, some of those fruit smoothies, even if they were non-dairy, but there's several of these products that contain fruit. Maybe they're fermented, some sort of oat or something that's fermented. Those would have been in the high category. But there weren't too many any beverages that I could think of that were, other than fermented, that we considered anything. Most of those were in the low. I don't recall if some of the fresh unpasteurized juices were probably in the medium category, but I have to go double check on that. I'm not 100% sure.
The following question is, what is a typical survival rate for probiotics in food in the gastrointestinal system?
Oh my goodness, that's a really good question. So that depends on the microbe. It depends on the person consuming the microbe. You know, depends on if the microbe is part of a food, if they're in a fasting state, a non-fasted state. And so I can't give you a precise answer, but I would say that you're probably, in general, you're going to lose a log worth just going through digestion. The stomach is pH 3, maybe a little bit higher if under certain conditions, maybe as low as 2, which will inactivate lots of microbes. For probiotics that are in supplements, many of them are coated with kind of protective agents that might protect them against some of the damage that can occur along the way. But even if you lost a log's worth and you're consuming 10 to the 9th, you're still getting 10 to the 8th reaching the gut, which could probably have an impact.
The following question is, how much biodiversity is found in the high category foods?
How much biodiversity is found in the high category foods? That's a great question, and so that it depends entirely on the food. So yogurt that contains maybe 10 to the 9th microbes has low diversity because it's mainly the yogurt microbes, which could be as few as 2 microbes to make yogurt. Whereas kimchi or sauerkraut or a naturally fermented vegetable could have many, many, many more microbes. And so relatively speaking, compared to yogurt, that would be a much higher diversity of microbes. And then there's in between probably some cheeses that might be made with a starter culture, and that might be the predominant microbes. But if it was a raw milk cheese, then there'd be other lactic acid bacteria and others that would contribute to the diversity of those foods. So again, it depends. Generally, starter culture foods will have lower diversity, high numbers, but lower diversity than foods made with a so-called natural fermentation, where there's no culture added, where we simply rely on the resident microbes to perform the fermentation.
The following question is, are mixed dishes a sum of their parts, or are more complex microbial matrices created? For example, additive microbial profiles, or synergistic or antagonistic?
Okay, I'm going to have to ask you to repeat that one more time.
Yes, sorry. Are mixed dishes a sum of their parts, or are more complex microbial matrices created? For example, additive microbial profiles, or synergistic or antagonistic?
Okay, I'm still not sure I understand, but
So maybe I can help it. Basically, when you eat a meal and you've got different kinds of microbes in there, is it possible that they're synergistic, I guess, in their effects on health, or antagonistic?
okay. That's an interesting question. There'd be I would say that the chances that they'd be antagonistic are probably pretty low. It's certainly possible that some microbes can produce antagonistic agents against other microbes, but for the most part, the microbes in fermented foods get along pretty well. So I would say that I wouldn't say that they're synergistic either. They're probably all working independently, but it's possible. For example, I could think of in terms of the degradation of complex fibers, that microbes can work as a community to degrade certain xylo-oligosaccharides or ribose islands, to break them down to feed the entire community, but would take a community to degrade those complex fibers. So that might be a way that they can work together for the benefit of all.
Thank you. The following question is, what should one look for when selecting a supplement for an adult and for an adolescent?
A supplement for?
An adult and for a teenager.
An adult.
Teenager.
An adult.
I'm not obviously in a position to recommend any particular brand of probiotic supplement. There are pretty good guides that you could follow. The ISAP website has guides for that, for probiotics that have been clinically demonstrated to support various or reduce the risk of various conditions. And so I would encourage you to go to the ISAP website for that. But there are strains, so you have to be very strain specific at that point, that have been demonstrated to have whatever it is that you're looking for, whether it's allergy reduction, some sort of asthma reduction, or whatever the benefit is that you're looking for.
Thank you. Are there any safety concerns, for example, for certain individuals with including foods with live microbes in the diet?
So for the most part, the answer would be the risk, any kind of safety risk would be low, because these are microbes that we've been consuming for thousands and millions of years, perhaps. But there are concerns that I would just point out a couple. One that is being studied now is the possible transmission of antibiotic resistance genes through microbes that are in fermented foods. So that's certainly relevant. For the most part, starter culture companies will screen the microbes that are going into yogurt and cheese and so forth to make sure that they're not transmitting those genes. But in wild fermentations, there is no screening. And the other potential problem is with microbes that can produce biogenic amines, which is also a pretty rare phenomenon, but can produce a mild form of food poisoning, but pretty rare.
We have one last question. How is the quantity of live microbes in a food typically assessed, for example, in the literature that was used as the basis for the 3 NHANES categories in the NHANES surveys.
Can you say that one? Say it again one more time? Or Maria, can you?
Yeah, it was just that you talked about going through the literature for the NHANES study as a way to categorize, but how is the level of live microbes typically assessed in the literature? I think that's what
Most of the literature relies on the traditional gold standard, which is plate counting. And so most of the data that's in the primary literature is from culture plating, and that's what we relied on.
All right.
Thank you everyone for the great questions. And I turn this over to Marie for closing comments.
Great, thank you, Maria. So that brings us to the end of the time today. A reminder that we'll provide access to the CEU certificate after the webinar. So a huge thank you to everyone that participated and offered your great questions. And an even bigger thank you to our speaker today, Dr. Bob Hudkins, for sharing his insights. So please go ahead and visit the IFIN's website under continuing education. You can find the rest of the webinars in this series, as well as others that have been approved by CDR. So thanks again, everybody, and have a great afternoon.
Thank you. Those were great questions.